Welcome back. So I have another problem on application of Newton's second law of motion. So we have the problem to protect a 17-kilogram pack from bears. A cab hangs it from ropes between two trees as shown in the figure below. What is the tension in each of the two ropes? Now, to solve this problem, the first thing we have to know what are the relevant forces acting on the pack, and then take the pack as an object. So this is a main object of interest. So this is the pack. And then resolve forces both in the vertical and horizontal direction. That will be able now to enable us get the tension in the ropes given. So we'll say to protect to keep the pack from accelerating, then all the forces acting that sum up to 0, i.e. A equals to 0. And then that should say that the force the net force is 0. Since force is given by mass times acceleration, so when acceleration is 0, then force or the net force will be 0. So the forces acting on the pack are gravity, that's weight, and tensional force in the ropes. Those are the forces acting on the pack. So let's go to the diagram and draw a free body diagram on the forces acting on this pack. So at this point where the pack is tied, I can draw a horizontal line. Now, because there's something that this is a straight line, then this is the same as theta, and then this is also the same as theta, because this is a horizontal line parallel to the line I've drawn where the pack is tied. So then now, I'll draw this diagram. So I draw my x, y axis at this point. So this is my vertical axis, then this is my horizontal axis. So I can now shift it and draw it clearly at this point. So this is the x, this is the y, and so this is a point where the pack is tied to those two ropes. Now I call this one T1. Let me call tension in this rope T1, and this other one I call it T2. Now, this angle is theta, and we know the value of theta is 22 degrees. So this is theta. So what we do, we draw right angle triangle to resolve these forces. So draw right angle triangle here. So this 90 degrees, this 90 degrees, and then this is the direction. So this is the direction, this is the direction, this is the direction, this is the direction. From trigonometry, it should be easy for you to see that this will be T1. So this is the tensional force, the magnitude of this hypotenuse is T1. Now without the arrow. And then similarly, on this other one will be T2. So this will be T1 sine of theta. This will be T1 cos of theta. This will be T2 cos of theta. This will be T2 sine of theta. So resolving for x components, that's the horizontal forces. So we'll have forces acting. Remember this where we have the weight of the pack. This way I have the weight of the pack, W. So horizontal forces are the horizontal forces will have this now. Those acting toward the right hand side, they are taken to be positive, left hand side negative. So this will be T1 cos theta. And then this other one is taken to be negative. So we'll have negative T2 cosine of theta should give us 0 because we expect the net force to be 0. There's no acceleration. So, which means T1 cos theta is the same as T2 cos theta. And then, so this tells us that T1 is the same as T2. So you can just call it T. So call it equation 1. And then vertical, that's mean vertical or y component. So we'll have this force T1 sine theta plus T2 sine theta minus W should give us 0, because now this acting downwards taken to be negative. So because T1 equals to T2 equals just T, so this is like we have T2T sine theta. Because I replace here by T, I replace this by T equals to W. So it tells us that T itself will be W over 2 sine theta, which is the same as mass times gravitational acceleration over 2 sine theta. And mass is 17. So 17 times 9.8 over 2 times sine of 22 degrees. So 17 times 9.8 divide 2 sine 22. That gives us 222.3666,146 newtons. So therefore, the tension in each rope is 222.54 newtons. these to nearest 4 significant figures. So that's how we solve that particular problem. Thank you.